for release party today, and I want to say we actually released the first version of pgstat plans today. So this was already, earlier available, but not actually tagged. So we are actually releasing this today. Yay! But let me switch the screen share around and let me tell you what this is all about. So first of all, as a quick introduction, I'm Lukas. I'm the founder and CEO of pganalyze, but I'm also an engineer by trade, and I love coding still these days, and I do spend a good amount of my time coding, time permitting. Just for context, pganalyze does Postgres performance optimization, so we do a lot of work with query performance, with plan optimization, these kind of things. It's a good product to use for that stuff. But in today's talk, I'm not actually going to show you pganalyze at all, except for maybe one screenshot to give context on something, because this extension does not require pganalyze in any way. This is a data source, what monitoring products can use, right? So whether you use pganalyze or you use SolarWinds or you use Datadog, you can hopefully eventually benefit from this as well as these providers integrate with this extension, and it becomes more widely available. So I'm basically, just for context here, this talk was originally given at PGConf Dev, and I made some modifications here. But if you're wondering, why is it so technical? Why does it go into all the nitty-gritty details? It's because I, wanted to give context to the audience at PGConf Dev. I'll do it a little bit more lightweight here because I know not all of you in the room are Postgres hackers, probably. But definitely feel free to ask me questions about how this stuff hooks into Postgres. So I'll first of all talk about the concept of a plan ID. And when I say plan ID, really think of this as basically when you know pgstat statements, right? Pgstat statements in Postgres is a kind of contrib extension, so it's bundled with Postgres, technically not core Postgres, but like it's always there on the Postgres install. And pgstat statements gives us query statistics where they get grouped by query ID plus some other fields. The point of a plan ID is basically to do the same thing with plans, and I'll go into more details on how that works. I'll talk a little bit about the status quo of plan statistics. So if you want to do this stuff before pgstat plans existed, then I'll tell you the context. And then in case you got confused at any point, by the way, there is an really old pgstat plans extension that Second Quadrant at the time published more than 10 years ago. That extension is no longer maintained. We built a completely new from scratch extension, but we decided to basically reclaim that name because it was clear the other one was unmaintained, and we think it's a good name. So just for context, if you're looking at the other extensions out there that exist for plan statistics, you might stumble upon the older pgstat plans. Now, third, I'll kind of explain a little bit about why I try to do this stuff in core, and I'm, an infrequent Postgres contributor. I have some patches in Postgres, but not a lot of complex patches yet. And so I got some stuff into 18 that helps with this extension, thanks to some folks, obviously, who contribute to this, not just my effort. But then, really right now we're basically, in an extension. So I'll explain some shortcomings of that. And then last, I'll talk about the new pgstat plans extension and kind of show you how it works. If there are questions, I'll take them at the end, unless somebody gets really confused. Feel free to interrupt me, but otherwise, probably easiest if we just go through it at the end. So why do we need a plan ID? So basically, it's the difference. Like if you look at a query ID, what does it do? It differentiates by the query structure, right? It's like when Postgres calculates the query ID, it looks at the parse tree and it says, gives each node in the parse tree basically a hash value, sums it up together. That's the query ID. Now, the plan ID is the same idea, but we do this with the plan shape. So we do this basically with, here's a sequential scan, here's an index scan, here's an index scan, this other index, right? Like it basically helps us know which kind of plan was chosen. And one of the ways I like to think about this is when you look at explain with costs off and without analyze, you're basically getting what I think of as a plan shape, which is the rough structure of a query plan, right? It's like it doesn't tell you how the costs were, it doesn't tell you what actually happened, but it does tell you which indexes were used, which join order happened, was the merge or hash join. Like it gives you all this information about the structure of the plan. And so I think basically what we're trying to do is we're trying to say, if this structure, if this shape changes, then it should be a different plan ID. Now, this is the one pganalyze screenshot I did mention that will come up. So the reason why I care about this stuff is because I want to know when plans fall over, when plans regress, and I want to be able to have our customers know that. And there isn't a good data source for this today, right? And so the reason I care about this is because we can actually know for a given query when, how often did the query use which of the plans was faster or slower, right? So it really helps us, understand when suddenly Postgres decides to do an analyze and the analyze messes with our statistics and suddenly we get a worse plan than before. You can kind of infer it from some existing data sources, but to really know this, you need some sort of aggregated plan statistics data. And also, they let us detect regressions quickly, as said, right? So this is just one comment I found where somebody in Hacker News was saying, they're a huge fan of Postgres. They think this was a user error on their part, but they got bit pretty hard by that user error, which is a query plan changed on a frequently run query on a large table, and suddenly, that went from sub-millisecond to multi-second. And you can imagine if you have a query running 1,000 times per second, if it becomes multi-seconds, that will take down your database, right? And they followed this up with saying the Postgres query plan is generally very good, but also very opaque, right? Which I kind of disagree with. I think the Postgres planner actually is very logical if you really get into it, but it's hard to understand if you're just trying to run a production database without becoming a hacker. So with that, let's dive into what we have today. So first of all, I didn't think of this idea, right? As mentioned, there is actually a pgstep plans that exists today, which coincidentally was created by Peter Gagan in 2012, roughly around the time we started pganalyze, or I started pganalyze. And basically, unfortunately, this was very good, very interesting, but it kind of fizzled out at the time. Like it never actually really became a thing that people were using. But one of the things that did happen is some of these ideas that were in that extension at the time did make it into pgstat statements, right? So Peter Gagan did contribute early on to pgstat statements in Postgres. And so some of the things that happened in pgstat plans at the time are now in pgstat statements just conceptually. But obviously pgstat statements does not track query plans. So yeah, don't use the old one. It's unmaintained. It has real problems. Like really don't use it. There are open source alternatives, and I don't want to talk badly about them because I think some of them might be viable. But the one thing I have seen, and none of the existing open source extensions that I found that do this, do it in a low overhead way. So basically, the way see, do I have a slide for this? Yeah, there we go. So PG store plans. Which is generally a good extension, right? Don't get me wrong. But the one thing it does, which is really expensive, is it calculates, the way it calculates this plan ID is for every execution of the query, for every execution of every query that, it samples basically if you use a sample rate, otherwise it's every query, it will do an explain on the text, and then it will hash the explain text. Now, obviously, if you do something like this, you care about the explain text, but you don't want to do it for subsequent executions, right? Like if you execute the same query 50 times, you don't want to do an actual explain, generate the text all 50 times. And so this, in some cases can have about 20% overhead for your actual workloads, right? Which is a big problem, right? Like I wouldn't want to enable something that has 20% overhead. pgstep monitor, which does a bunch of things, but also optionally can track query plans, which you have to enable. But if you do enable that, it does the same thing as PG store plans. So it also calculates the plan ID based on the text. And again, same problem, right? Like you just have too much expense if you do this on every execution. It's just too expensive to do this text generation and then hash a big text. In 2024, AWS actually launched something on Aurora, which, speaking, we spoke before we started recording, we spoke about, Postgres open source and kind of proprietary forks. Now, here's an example where I'd love, for AWS to have contributed this back to the community. They didn't, unfortunately. So that's why, I'm here trying to make this extension happen. But they basically launched something called Aurora Plan Stats, which does exactly what we wanted to do. It's exactly the right thing, right? So if this was available everywhere, we should just all be using Aurora Plan Stats. But it's not, right? Like it's only available on Aurora. But it basically does what we want, which is it tracks, statistics in a low-ish overhead way, and we can get that information. Also, Microsoft has something they're saying they have in Query Store, but it's kind of hard to find out what it really is, and it's also not open source, right? So there exist these solutions. And in fact, part of the reason why I'm interested in this is we actually did integrate with Aurora Plan Stats. So if you are in Aurora, pganalyze actually pulls in those stats. It just happens to be that a lot of people are either in RDS or in other providers where that's not available. So yeah, the question is, can we do better, right? Like that's kind of what I set out to figure out.
Hello.
And good. Was there a question? No, okay. All right. Um, the question really is, right, can we do this in core versus an extension? And obviously, the conclusion of this, which is I did end up figuring out a way to do it in extension. But really, the core requirement here is this must be fast, right? Because we're doing this with every planning cycle. So adding overhead is a problem. And so we cannot hash to explain text, basically. This is, too expensive, right? Like the explain print plan is kind of the internal explain function in Postgres. Now, here's where it gets a little bit technical, as in like Postgres hacker technical. So basically, what we want to do is we want to do a tree walk, right? So if we're looking at a query ID, what that does is it looks at the post parse analysis tree, which is once Postgres basically turned the SQL text into an AST, and then it assigned kind of it figured out which of the references points to which table. That's the post parse analysis tree. That's before planning, and so the query ID gets calculated based on that. Now, the plan ID should do the same thing, but for the plan tree, right? And obviously, this stuff works for the query ID. So we just got to do the same thing for the plan ID. And then Postgres has this jumble mechanism, which is basically a hashing mechanism, which, walks the tree and calculates significant parts and then calculates a hash function. The one thing that I kind of got frustrated with here, and unfortunately, it still holds true today, is this is a little bit messy to do out of core. And I tried to get, our dear hackers community to get something in Postgres. And, I obviously had to compromise, which is always how it works with Postgres. Community projects, right? Because basically, one of the things that's challenging here is, let's say we have an index scan. An index scan node in Postgres has a list of quals, which are basically expressions on that, like the index, what actually gets put into index condition, I believe. And so one of the challenges here is it says here in the source code comment, it says usually these quals are op expressions. Op expressions are like, x equals 1 or something. But the problem is the word usually. And there's kind of this long tail of things you need to think about when you look at these expressions that show up in these plan trees, which are ultimately all like it gets as complicated as the query ID basically because you might have very complex expressions. And so that makes it tricky to be out of core because you suddenly have to reinvent the logic to calculate and hash these expressions. In core, this is easy, right? So in core, there's a mechanism where you can go to each of the plan nodes in the source, and you can say, if you do a hash, if you do this jumble, include this field, don't include that field, and then there's an auto-generated function that actually lets you, kind of generate basically a big C file that calculates the hash, which is really great. Like that's really convenient, but you can't do this outside of core easily. If you're interested in nitty-gritty details, there is a wiki page on the Postgres wiki about this whole plan ID jumbling hashing logic, where I basically try to argue for which things are significant and which things are not significant. I won't delve too much into this, but if you are interested in this, there is a hypothesis behind what is considered relevant for the plan ID. And then this is a detail, but there's a slight optimization that we can do in core that we can't really do outside of core, but it's fine. It's not a major issue. Well, obviously, none of this stuff got into PG18 except for one thing that luckily did, which is that we now have a plan ID on plan statements in Postgres. So basically, what this lets us do is if we are an extension who's interested in doing this kind of stuff, which is interested in doing this kind of stuff, extensions can calculate a plan ID, can assign this to this plan statement, and then later on reference it again. And it seems very simple. It actually is relatively simple. Like it's literally a single field on a particular struct in Postgres plus some helper functions. But what that means is you can, like what it ultimately benefits us, and I'll show it to you later, is it lets us show the query plan for a currently running query before it finished execution. So without this commit, we basically cannot show you the plan before things finished executing because we don't really have a place to attach to. Versus with this, we can basically say this PID, this connection is using this plan, which turns out to be extremely useful, right? Because if you have this runaway query problem where suddenly, you're 100 1,000 times a minute query turns into, a multi-second query, a lot of them won't finish, right? Because it's just way too much overhead. And so then you're interested in, if I look at stat activity and I see, 100 backends kind of all active, I want to know what plan are they using. And so this is the key piece that lets us do that, basically. So yeah, we can now write an extension on Postgres 18 that uses this plan ID field. All right, well, let me show you some of the stuff of how this actually works. So this exists on GitHub. It's Postgres licensed, so feel free to take it, recreate it, modify it. If you are, I don't know, GCP and you want to have this stuff, feel free to fork it and incorporate it into your, proprietary Postgres services. It's all fine by me, right? This is intended to be used by the community, and I'd love for people to contribute to this. And we already had one PR that fixed some of the things that happened in Postgres Beta 2, Postgres 18 Beta 2. But yeah, basically, this exists as something that I'm trying to get adopted because I think it's missing in the big picture. And if there's stuff that gets in the way of it being adopted, I have a goal to resolve these things. And I think other people probably share that goal. There's a note here in the README that says experimental, and that still kind of holds true. So basically, I feel like it does need a little bit more baking before I put this on a serious production system, just because it hasn't seen a lot of real world deployment yet. So all of you here, if you have time to test something on a local Postgres 18, or I'll get to this in a little bit, 16 or 17, you can test this extension and you can help basically get this into a good production tested stage. One of the other things this extension builds on, and I think this is the last time I show a Postgres commit message, is it builds on what's called the pluggable APIs or custom cumulative statistics. So cumulative statistics, hard word, is basically the subsystem in Postgres that as of, I want to say Postgres 15, something like that, that helps us track shared statistics in shared memory. So before, like a long time ago, Postgres used to have this stats collector process, and internally in Postgres, statistics would be sent around, and it had all kinds of problems. Now, what Postgres uses internally for things like, table stats, like how many, index scans happened on a table or sequential scans happened on a table, that's all in the cumulative statistics system. Before Postgres 18, you couldn't hook into that system. So basically, it was only reserved for core Postgres. And this change here, basically, which I did not contribute to at all, to be clear, this is other people doing the work, but I think it's a great benefit, basically. This change here enables that you can, as an extension, now also use this cumulative statistics system. And one of the main benefits this has is it has some, well, it saves you a bunch of code, first of all. And second of all, it lets you do things like flush statistics with a delay. So basically, if you don't have this, you kind of have to write stuff to shared memory more quickly, and then you have to put a lock on that, and that lock can have contention. And so the cumulative statistics system has a way to reduce that lock contention by basically delaying when statistics get added up on the shared memory stats infrastructure. And so without having this in the extension, you could still use shared memory, but you'd have to basically reinvent the wheel, and it has a little bit more overhead, which I'll get back to that in a moment also. But yeah, basically this is a key commit because it made a bunch of the stuff easier for me to actually build something like this. All right, well, enough talk. Let me show you how it actually looks like. And I do have it running locally, maybe also, but I'll reserve live demos for, maybe if I have to, but it's always easier to put stuff on the slide. But basically, I did run this previously. And the way this works, right, is, again, if you're familiar with pgstat statements, it's very similar in the mechanism, right? So you have a new view called pgstat plans that calls a bunch of stuff internally. That view groups each plan by the user ID, the database ID, whether it's top level or not, aka if it's in the function or not, query ID, plan ID. And then it tells you how many calls happened, what was the total time that this took, so you can divide this by calls and get the average, and then the plan, right? This is the explain costs off version of the plan. So we could obviously add a lot more things to this, but even this alone already lets us do something really important, which is we can look at that query ID. We can basically get the query text from stat statements, right? It's the same query ID. And then I can say, for this SQL statement, what were the plan shapes that we saw, right? Like, was it a bitmap heap scan on database stats 35D? Was it, something else? Like this, we can basically now track with pgstat plans. Behind the scenes, what this does is it calculates the plan ID with a tree walk after planning. And then the part that's kind of ugly, but that's the trade-off here is I had to copy a bunch of code from Postgres, and that's also a little bit of a maintenance burden. Not too bad, but like it's basically today some of these Postgres extensions that do interesting things, and this is mildly interesting. Maybe there's definitely more interesting extensions out there, but many of the interesting extensions have to copy a lot of code from Postgres because code isn't always accessible to an extension, right? Like it's sometimes static functions in a unit file you can't access, which is kind of frustrating, but it does work, and we kind of built the whole extension system like that. So kind of that's what I had to do here. And then the plan text, and this is also a key design here, is that the plan text is not stored on disk. So if you know pgstat statements stores its query text on disk, which is both good and bad. So at pgconf we had an unconference session where we talked about kind of the future of pgstat statements and how can we improve pgstat statements. And one of the things that's in consideration is moving pgstat statements to use shared memory instead of a file on disk for query texts, at least in the most common cases, because it turns out if you have a file on disk and you have a lot of activity on that file, that becomes a bottleneck. And also, if you load that file a lot, it just the I/O can sometimes be an issue. Obviously, we figured out how to make this work, right? Like our whole product is built on pgstat statements in many ways, so this does work. But I do feel that the thing that we've chosen here is basically with pgstat plans is using dynamic shared memory. Dynamic shared memory basically means shared memory is shared between all the backends in Postgres, right? So the different processes can access the same memory space. And then the dynamic piece here means you don't actually tell it ahead of time how large it is, right? It's because obviously, plan texts can have different sizes. You might want to change how many plans you're storing. And so that's where the dynamic portion actually lets you resize that shared memory segment. The other key thing that we did add to pgstat plans is making it compressible with C standard compression, because you are in memory, right? Like you're trying to basically reduce how much memory you're using, and this is a bunch of text, it compresses well. And so this is one of the ways how you can, with a little bit of additional CPU work, you can basically save the memory so that, it's, I forget the exact, maybe I have it on the next slide, but like basically, it's the tens of megabytes that of memory that you need versus, you don't, even if you have very complex plans, you don't need a lot more than that. So. Now, the key other thing that I think is really cool is you can get the plan for currently running query, as I mentioned earlier. So what does that mean, right? I can query the pgstat plans activity view that one joins an internal function against pgstat activity, basically. And what it shows you is for this PID, what is the plan ID and what is the plan, right? So the query doesn't have to finish. I can actually see what the current plan is right now. Extremely useful for runaway queries. Obviously, I don't get any execution statistics with this, right? So I don't know how far along the plan is. There are efforts in Postgres and core Postgres to try to get some kind of query progress tracking going, but those are a lot more complex. This doesn't do any progress tracking. This just says what plan did the planner choose. And then here's some benchmark results, right? So the nice thing about pgstat plans is it has a lot less overhead than the existing extensions. Higher is better here. So this is a PG bench on a somewhat beefy AWS instance. This compares 17 default versus 17 PG store plans, right? That other extension, you can see that big dip in the performance. So don't use PG store plans in production, unfortunately, is what I would say. And then 18, I basically did a comparison, just, baseline, then turning on pgstat statements, which had surprisingly high overhead here, might have been a benchmark. And then pgstat plans with pgstat statements, that's, that second line, which is should actually be lower than pgset statements. I think there's a little measurement issue there. But then really the key thing that I wanted to show here, right, is like we're not actually losing much of any performance. And if you just do the pgset plans piece, you'll actually see that itself clearly performs better than using stat statements, which in part is because of that query text file, right? So stat statements actually has higher overhead than if you just use pgset plans without the queries. Not kind of a realistic use case, but it's basically my point here is I think this is from performance overhead perspective, this should be safe to use on production without much worry. Yeah, what are other things that I want to do? So basically, the plain text compression is still relatively basic. So I think there's some things to do there. The extension, obviously, well, stabilize here mainly references testing and benchmarking, right? This is where all of you come in and can help us test this on your own things. And then the last piece I actually did get done, so I should have crossed this out ahead of time. And I just got it done early this week. So I was very busy this week. So I did actually figure out a way to make Postgres 16 and Postgres 17 work. The one thing that we're missing is this piece here doesn't work because, as mentioned, that plan ID isn't there. But basically, we're getting this core functionality here, right? Like being able to query which plans exist and how often they run. That part actually does work on 16 and 17. And what I did is I basically went back and I did a backport of this kind of. It's not actually a backport because it's not an actual core Postgres. It's basically a big C file that copies even more code. But it works. And so if you're interested in using this in older releases, I have something that works at least on 16 and 17. But yeah, the point is we can actually use this even on 16 and 17 today. There's some open questions here, and if anybody of you have thoughts on this, I definitely welcome them. Or GitHub is also a good place to discuss them. So one of the things I'm not sure about is how to handle partitioning, right? Like what I call append notes here. So if you have a plan and the plan, let's say you have time series partitioning, and you add another day partition, suddenly your plan ID changes because you're looking at another table, right? Like the hash, the plan ID hash changes because there's another node in the tree. Now, what that means in practice is that for any query that uses partitions, you'll get a lot of unique plan IDs. And that doesn't seem like the right trade-off to me, just because it makes it kind of hard to use, because you don't really see if the plan changes in more substantial ways. And so what I'm currently thinking for partitioning is we should probably have a way to say, ignore partitions or squash them or normalize them somehow, so that if, a plan uses just different time series partitions, we can just, like it's the same plan ID still. So that's one of the things I'm kind of pondering about. I think there's a question, which metrics should we capture? So right now the extension just captures calls and total time. But I think we could easily capture, buffer hits or something, like any of the pgset statement statistics are easily available. It's just not clear if that's actually useful because you already get them from stat statements. So why, like what are the things that are actually interesting to know on a per plan basis? Right now, it always does a text format explain in the kind of text that it shows you. It's not clear if it's necessary to support other formats. Like if you are trying to do machine parsing of the output, maybe it's nice to do JSON or YAML. But I don't like, for what we see in pganalyze, it doesn't seem necessary. I think we can make it work based on a text format basically. And then there's also a question, as pgset statements evolves, maybe this should actually be part of pgset statements, right? Like, should we really have two separate extensions? I'll preempt one question I got previously about this because it may be interesting to this audience. So the other thing I don't have a slide for is, should I use auto-explain when I have pgstat plans, right? Because auto-explain exists today in Postgres. Auto-explain is a sampling-based, log the query plan when something is slow. And just to basically share that one last piece is, I think there is a use case for auto-explain still, because execution statistics aren't, like outliers aren't really captured in this approach, right? Like what we're capturing with pgstat plans is we're capturing the shape of the plan, but we're not capturing the exact statistics of the ROMIS estimates and IO time and such. And I think ideally, basically, once this is in production ready, everything, all the good stuff, you probably would want pgstat plans plus auto explain, so that you really understand, both which plans get chosen, and then also for the ones that are extremely slow, you actually get the execution stats as well. All right. I think that's all I had. Let me see. Yay. True. Cool. Well, as mentioned, let me just do one really quick change to my screen share again. So this is actually live. You can go on GitHub right now and check it out. We did also the one decision I had to make this week is, so in the Postgres wiki, you have to claim the numbers for cumulative statistics because it's a finite ID basically. And so I successfully claimed the first number on this list, which always feels intimidating. But this here says when the project is close to release or being used in production, choose an unused stats kind. So it's close to release, it's released. So we're officially number 27 in the custom stats list. So take that as you wish. But this was an important thing to basically get done as well before the release. So that's all. Thank you, everybody. And I'm happy to take any questions.